Hey, grade nines. For this next lesson, this is lesson 3 now, on unit 2, we're going to go over how to add and subtract polynomials. So this lesson should hopefully be a little bit easier compared to the last one we just did. There's a little less content and hopefully makes sense. First thing is just a reminder of what like terms are. So we talked about like terms in the very first lesson in this unit. Reminder, like terms are essentially terms that have the same variable and the same exponent. So it has to be both conditions, right? So we have to have the same variable and the same exponent. They don't have to be the same sign, and I think sometimes people have a misconception about that, or that they have to be the same number. They literally just have to have the same variable and the same exponent, right? So just a reminder here, we have something like 2x squared and negative 8x squared. These are obviously like terms because the variable itself is the same, and of course the exponent is the same as well, right? Or something like 4xy and 5xy, right? So these are still going to be the same because they have the same set of variables, right? And the same exponents. So they have to have the exact same variables and the exact same exponent and the same exponents for each of the variables there. So if we have like terms, then there's actually quite an easy way to work with it. Basically, we find the sum or the difference of terms by simply adding or subtracting them. And specifically, what I mean by adding and subtracting them, you add or subtract their coefficients. So the whole idea there is that if you have like terms, they have so they are actually confirmed to be like terms, so they have the same variable, same exponent, then you can simply add or subtract the coefficients, and the coefficients are the numbers that are in front of the variable. Okay, so some examples here. If I ask you to simplify this expression, so we have 5a and 4a. Well, if I'm asking you to simplify 5a and 4a, at 5a plus 4a, I notice that first they are like terms. So because they are like terms, I can definitely add them up. So I'm going to add them by simply adding their coefficients. So what that means is I take the number in front, 5 and the 4, and I simply add them up. So 5a plus 4a would give us 5 plus 4 in front of the a, and that gives us 9a. So I'm showing you this bracket here. This is literally just to show you the work. You don't have to do that, right? You can simply add them up. 5a plus 4a, I think everyone can see. I can just add up the coefficients. That gives me 9. And it's 9a because I'm adding up the a's themselves, right? So you almost want to think of it as like, I know it's very simple. It seems kind of like a weird, simple example to give, but something like, imagine that A represents apples. I'm just doing this randomly, right? So if A represents apples and I say, you have 5 apples here and 4 apples there, how many apples do you have? You have 9 apples. And so we simply write 9A. So a big error that people make, and this is extremely common, and it's tempting. I don't know why, but I think it's just because of the way it looks. To want to add these up, and then people almost think like you have to do more to it, right? I don't know. It's just human tendency, right? That you want to maybe think that there's something else to it. So people sometimes add the square there. This is not correct. And again, I think the best way to think of this so that you don't ever get it confused is think about real life. If I were to tell you that you're measuring, let's say you're measuring perimeter, right? Or you're measuring a length, like you're just trying to measure out like 2 different lengths here. If I tell you that you have 2 meters and you have 5 meters, and I say, okay, well, how much do you have altogether? You're not going to tell me I have 7 meters squared, right? I think everyone can understand that 7 meters squared wouldn't make sense because if I'm asking you to add, 5 meters here and 2 meters there, I'm obviously not talking about area, I'm talking about length across. So it's all one dimensional. So your answer, when I add them up, it should still be one dimensional. So if you were to give me an answer of 7 meters, that makes sense because I'm simply taking 5 meters plus 2 meters and I add them up, I get 7 meters. But if I put a square there, that does make no sense at all because when we're talking about 7 meters squared, I'm talking about an area. And this is an area. We're actually looking at just the dimension, a one-dimensional. We're just looking at, we're just working with one dimension here. So this is a good, hopefully real life example where you can kind of see it doesn't make sense for you to actually add them up, and then change the exponent itself. So if you're adding values that have the same units or they're like terms, you simply just add the values, and you don't have to change the actual units or the actual variable in this case, right? You just add the numbers in front, right? And like I said, it's quite easy. And sometimes when something is a little easy, people tend to just want to overcomplicate it, but it's really not, right? I'm hoping you kind of understand that so far. So a couple more keywords. Oh, by the way, just going back to this really quickly, can you subtract? Absolutely. I know we haven't done that yet, but if I ask you to subtract it, so in this last example, if I say 5a minus 4a, you can pretty much guess what you're going to do. You're going to take 5 minus 4, and 5 minus 4 is 1, and so you write 1a. Or there's an easier way of writing 1a. I can simply just write a, right? And so it's just the same as the going back to that old example, right? You know, about apples, 5 apples minus 4 apples, you have 1 apple, and you technically don't have to say 1 apple. If you say an apple, or sorry, an apple, I said it weird, then, you know, it's implied that you're just talking about 1 apple there, right? So you don't technically have to write the 1 in front, but you can if you want. Okay, a couple more keywords, because we're going to be using this quite a bit. Monomial is an algebraic expression that has one term. So I'll kind of put the bikes here just to kind of, so you kind of see what I mean by this. So different types of bicycles that we have, right? So actually not bicycles. So we have a unicycle, a bicycle, and then we have a tricycle, right? That's kind of explains where all these words are coming from, right? So monomial basically just means one. So we have only one term there. A binomial is an expression that has two terms. So just like we have two wheels here, we have two terms here. So we have 5x plus 6. This would be an expression of a binomial. And a trinomial would be an expression that has three terms, right? So in this case, it's just like the tricycle, right? We have three wheels there. And that would an example of that would be something like 6x squared plus 2x plus 3, because we're adding the three terms there. And finally, a polynomial is an expression that contains different monomials, right? So essentially what we're saying is well, actually the word poly, I don't know if you know that word poly, that's prefix there, it means multiple, right? So if we say polynomial, that means that it's any number of terms, right? So it could be one term, it could be two terms, it could be three terms, it could be 10 terms, right? We could have actually a lot of different terms in there. Essentially what we're saying is it's a whole mix of terms, right? And it's not necessarily restricted to 1, 2, or 3. It could be more than that, or could be a little less than that, right? There's actually a little bit more detail to this definition. It's not that easy. There's a couple more conditions in order for it to be a polynomial, but for now, we're going to stick with the easiest definition, which is essentially an expression that contains multiple terms, okay? So not just one term or two terms or three terms exactly, but it could contain multiple of them. So how do you add or subtract polynomials? So just so everyone's clear on this, in all these examples, we're just going to talk about polynomials. It won't be until the next lesson and possibly near the end, we might start talking specifically about monomials and then binomials a bit more. But for now, we're talking about polynomials, which again, is an expression that contains multiple terms, right? So it could contain one term, could contain two or three, or it could contain more than that, right? So when you're adding, so when you're adding and subtracting, it's a little bit different than multiplying and dividing expressions. When you multiply and divided expressions, we actually did that in the last lesson. We could apply exponent laws, and we could also multiply numbers by variables by putting them next to each other. We could apply the exponent laws in a lot of different ways, and it could simplify different expressions here. When you're adding and subtracting, it's a bit more strict. You actually can only add or subtract if they are like terms, right? And that's really one huge difference. You can't add or subtract if they are not like terms. And there's kind of no way around it. So as an example, if I give you something like 6x plus 7y plus 4, and then I ask you to simplify that, it's a bit of a trolling question here in a sense, because if I ask you to to find the sum of this of all these terms here, there's really not much you can do. If I were to add them up, I would simply just get 6x plus 7y plus 4. There's no way I can simplify that, because these are not like terms. There's no like terms between them, right? This has an x, this has a variable y, and this is a number. So because there's no like terms, then I can't actually do anything to simplify it. In this next example, let's see if we can simplify it here. So we have 5x squared minus 2x minus 6x squared plus 4x. Well, first thing I notice is that I do actually have some like terms. 5x squared and negative 6x squared with the sign in front, right? And it's a negative 6x squared because it's the negative in front. These are actually like terms. So because they're like terms, I can piece them together. So that means that I'm going to simply rewrite it so that they are next to each other. So I have them highlighted in blue here. You can see here that those two are like terms. And then I have negative 2x and positive 4x right there. Those two are like terms. So I'm simply going to make sure that I highlight them in the same color to kind of emphasize that I'm going to be adding them up together. Okay. And again, it's the sign in front that will tell you whether you add or subtract. So if the sign in front is negative, or it means you're subtracting, right? So we can, so another way of doing that, so another way of thinking about it is that we're simply adding a negative 6x squared, right? So we can think of it as subtracting, or we can think of it as adding a negative number. So what we're going to do next is we're simply going to move the like terms next to each other. This is just my personal step. I like to think of it, I like to piece all the like terms next to each other, so it's easier for me to do the math here. So I have 5x squared, and I'm going to subtract off the 6x squared there. So I'm going to simply write them next to each other. So I have 5x squared minus 6x squared. And then, of course, for my next step, I'm going to take negative 2x, and I'm going to add on the 4x squared. Sorry, 4x, not 4x squared. So my next step here, I have 5x squared minus 6x squared. I know that 5, obviously 5 minus 6, I can simply subtract off the coefficients there. So all I'm going to do in this step is simply take the coefficients and subtract them. And that's going to be the coefficient of x squared. So I have 5 minus 6. And the next expression, in the next two terms here, I'm going to notice that because they are like terms, I have negative 2x and 4x. I can simply add up the coefficients, the numbers in front, and I have negative 2 plus 4. So I add these two up, and I end up getting, in my next line, negative 1x squared. And why is that negative 1x squared? Because 5 minus 6 is negative 1. And of course, I add up the coefficients of the x terms. So I have negative 2 plus 4, and negative 2 plus 4 is 2. So I end up with an expression of negative 1x squared plus 2x. Now, just so you know, that the negative 1 there is decoration. I could take out the 1 itself and just leave a negative sign in front of x squared. You could definitely do that, but for now, it's fine if I just put a negative 1. So the importance of brackets. In that last example, we didn't have any brackets. Sometimes you are going to have brackets, and they do sometimes make a difference. So, okay. So we'll talk about when they make a difference, when they don't. So if you are adding polynomials, and this is an example of adding a polynomial because we have one set, one expression here plus another expression here. I'm simply adding them up. In this case, the brackets don't actually make a difference because what we're doing in a sense is we're almost separating them out together, right? We're saying take this expression here and take this expression here, and we're going to add them up. So it doesn't make a difference at all because you're adding on all these terms here. So I can actually remove the brackets, and it won't actually change the expression at all. So what we do here in this case is we simply take 5x squared, and we are going to be adding 4xy, and then we add 2x squared, and then we subtract off 7xy. So what we notice next, and obviously I kind of highlighted this for you, is that 5x squared and 2x squared are like terms. So because 5x squared and 2x squared are like terms, we can place them next to each other. And because 4xy and negative xy are like terms, we can also place them next to each other. Now what we notice next is that we can add or subtract the coefficients depending on whether it's positive or negative. We're going to add the coefficients of x squared. So 5 plus 2 ends up giving us 7. And of course, we're going to subtract the coefficients of xy. So we have 4xy, and technically there's no number here, But remember, when you don't see a number, it's automatically 1, right? There's a 1 in front of the xy. So we have 4xy minus 1xy, and that ends up giving us 3xy. So this simplifies to 7x squared plus 3xy. So what if, is there a case where the brackets actually do make a difference? So we are going to notice that in this next example, it does make a difference. If there is a negative sign in front of the brackets, it complicates things a bit more. So if I were to have a negative sign in front of a polynomial, so let's say that in this case, I have some polynomial right here. So this is the first polynomial. Sorry, I'm just trying to write it a little bit neater. Polynomial, this is the first polynomial, and then here I'm subtracting off another polynomial. I'm going to notice that in this case, because I'm subtracting off that second polynomial, I have to almost think of this negative sign. It's almost like there's an imaginary 1 in front of it, and I'm simply distributing this out. I'm distributing out that negative sign amongst the two terms there in the brackets. So essentially what I'm doing in this case is I'm saying I have that first polynomial 2y plus 3x squared, and I am simply going to subtract off whatever terms are inside this set of brackets. So if I'm subtracting off, I know that I'm going to be using the opposite sign, right? So in that first step here is I'm simply going to think of this as if it were like a -1. It's probably easier for me to think of it that way. It's almost like there's a -1 in front of that set of brackets. And I am simply going to multiply that -1 by each of the terms inside the brackets. And by doing that, it switches the sign of the terms there. Because really what I'm doing is I'm subtracting off the terms that are inside this second set of brackets. So because I'm subtracting it off, I need to switch the signs there. So in the next step here, I have 2y plus 3x squared. And this is where things start to change a bit. So in the set of brackets here, and I'm just going to erase it so it's a little more clear. In the set of brackets here, in the second set, we said that we are subtracting off these terms here. So if we're subtracting them off, then I'm simply going to switch the sign. So instead of me adding 7y, I'm actually going to subtract 7y. Instead of me subtracting 2x squared, I'm going to be doing the opposite of subtracting. I'm going to be adding. So I just simply change the sign in front of the terms. So that obviously changes my expression. And in this case, it definitely makes a difference on the answer, right? So my next step here is to bring the 2y and the negative 2y and the negative 7y together. So I'm going to take 2y plus negative 7y. And I obviously know that 2 plus negative 7 is the same as 2 minus 7. So I can simply subtract them off like that. So I have 2 minus 7 in front of the y. And that's going to, and again, the 2 minus 7 is going to give me the coefficient y. And then I do the same thing for the x squared terms. I take 3x squared plus 2x squared. And I know that I can simply add them up, and that gives me 5x squared. So altogether, I end up getting negative 5y plus 5x squared. And that's how I simplify that expression there. So again, just notice that the signs have to change when the expression comes right after a negative sign. So if you see a negative sign in front of a whole polynomial, you have to actually change the signs of the terms in the polynomial. So let's do another example here. So we have 2x minus 3y plus, in brackets, 3x plus y. So in this case, do the brackets actually make a difference? They don't make a difference, right? Because there's actually no negative sign in front. It's just you're just adding two different polynomials. So I'm taking this polynomial plus this polynomial here. So I can simply write it as 2x minus 3y plus 2x plus y, right? And again, I'm highlighting in Christmas colors here. I'm highlighting the terms that are like terms, and the ones that are a separate set of like terms, right? So obviously the 2x and the 3x are like terms. So because 2x and 3x are like terms, I know I can simply add up their coefficients. And I've been showing all the work, all the details for this, but I think at this point I don't have to as much. I think you were kind of getting it. To add up the like terms, you simply add the coefficients, right? So 2 plus 3 gives me 5. and that means I have a 5 in front of x, so we have 5x. And then for the next set of like terms, I have 3y and y. Negative 3y and y, and we know that negative 3 plus 1, and again, this is an imaginary 1, will end up giving me negative 2. So I'm going to have negative 2y. So my final answer is 5x minus 2y. And again, because and I hope everyone's kind of clear on this, because the answer when I added up these two like terms was negative 2y, I have to subtract off the 2y. That's really what I'm doing that. You technically could, and I always get this question, could you write this? 5x plus negative 2y. You can, but to be honest with you, it tends to get a little confusing because you don't ever really want to put the plus and the negative sign next to each other. You normally just want to simplify it by putting a subtraction sign in front, because really adding a negative is the same as just subtracting it, right? So just to simplify it, we tend to just think of it as either adding or subtracting. Let's do this next example here. So in this case, we see here that we are subtracting off a polynomial. We have one polynomial, so polynomial number 1, and we're subtracting off polynomial number 2, right? So in this case, it actually does make a difference. So because you're subtracting off this second polynomial, you want to switch the sign for this polynomial, right? So all the signs of the second polynomial there are going to change. So we have 3x squared minus 4xy plus 6y squared. We're simply going to change the sign of the second polynomial there. So we have in our next line 3x squared minus 4xy plus 6y squared. And then we are simply going to change the sign here. It's going to be minus 6x squared. And then instead of subtracting 8xy, I'm going to be adding 8xy. So I simply just change the sign here. And the last one, I was supposed to be adding 3y squared, but now I'm going to do the opposite. I'm going to subtract 3y squared. And so my next step here should hopefully be pretty easy. I'm going to collect up the like terms. I made your life a little bit easier in this case because I actually just all I did in this case was simply highlighted the key terms there for you. Sorry, the like terms there for you. So the x squareds, I highlighted them together in red. The x y terms, I put them in green, and the y squared terms I put in blue. So I kind of already did that for you. But just so you know, that would be your little step there, that if you're doing this question on your own, I would definitely group the like terms together, or highlight them or circle them, underline them, whatever you need to do so you differentiate the different like terms there. So in the next step here, I'm gonna simply add up the x squareds. So the x squared terms, we see we have 3x squared, and then we subtract off 6x squared. So 3 minus 6 is going to give me negative 3x squared. For the next one, I have a negative 4xy, and I'm adding 8xy. So I know that negative 4xy plus 8xy ends up giving me positive 4xy, because negative 4 plus 8 is 4. And then for the last one, I have 6y squared minus 3y squared. And I know that 6 minus 3 is obviously going to be 3, and that's how I got the 3y squared. Be really careful with this. Sometimes for some reason, people tend to mix a couple of the rules they learn. They look at this and they say, okay, I have positive 6y squared, and then I have a negative 3y squared. And so they're thinking of the multiplication and division rules with negative numbers. They think, oh, I have a positive and negative. I get a negative. This is a negative, right? We're simply just adding or subtracting the coefficients in front of the like terms, right? So because these are like terms, I'm simply going to be subtracting 6. I'm going to be taking 6 minus 3, which gives me 3. Okay. And of course, because it's positive, I just put the positive sign in front. So I hope that kind of makes sense there. So again, look at the sign in front of the term. That's going to tell you whether you add or subtract. Okay. So let's do a word problem here. So what if you have to set up an expression and then you have to solve it? So how do we do this? So this is actually one of the homework questions that I've assigned to you. So if you look on page 111, it's a question about a pool table that's being designed, and then figuring out how much, what the expression would be for the cost. So Sorry, I need a little coffee break there. So what we're going to do in this case is we are going to figure out what the expression is for the total cost of this pool table. So hopefully you'll get to read it step by step, and you can read all the details here, but I kind of summarize it here. Essentially, this pool table is designed so that the length has to be twice as long as the width, right? So if you want to picture this, I always find it really helpful to draw this out. So we have a pool table where this length right here is twice as long as the width, right? So we are told a couple things here. We're told that the rubber bumpers that go all the way across, they're going to cost $2.25 for every meter, and then the area itself, and I'll maybe highlight this in blue. Oops, sorry. I'll highlight this in blue. This area itself is going to cost $28 for every single meter squared. So we need to figure out what the total cost will be to create this table. So the first thing we notice is that we unfortunately need to know the length and the width. There's two different variables you need to know. And we don't know either one of them, right? But we do have a really key piece of information here. We're told that the length is twice as long as the width. So it seems like if we know the width, then we'll definitely know what the length is, right? Because the length will simply be 2 times as much. So another way of writing that it's going to be 2 times as much is to simply write that the length will be equal to 2w, right? So the width will be w, and I just went with something easy, right? Let the width be w, and then the length we know is going to be twice as long, so it's going to be 2w. So let's start with something. Let's start with the rubber bumpers here. I think this will be a bit easier. So we know that the rubber bumpers are going to cover all the way across here, right? And I hope that kind of reminds you of something important. That reminds you, hopefully, a perimeter. So really, for the first part, to find the cost of the rubber bumpers, we just need to find the perimeter of this table. So the perimeter of this table here, I'm just going to skip over to the main part here, is simply going to be length plus width plus length plus width. But in our case here, we notice that the length, we already has mentioned this, that the length is going to be 2w and the width is just going to be w. So I can actually change this to an expression that has 2w plus 2w plus w. And what do we notice? These are all like terms. So because they are like terms, then we are definitely allowed to just add them up together, right? So we add up these like terms. So 2w plus 2w plus w. There's an imaginary 1 in front of the w. So we notice that's 2 plus 1 plus 2 plus 1. And 2 plus 1 plus 2 plus 1 gives us 6. So that means that the perimeter is equal to 6w. And that's the expression for the perimeter. What about the area? Well, for the area, we have, we know that one of the sides, and I'm going to redraw this underneath so you can see it. We already said that the width was w and the length was 2w. So if I want to find the area, all I need to do is take 2w and multiply by w. And what does that reduce to? What does that expression become? Well, 2w times w. This is kind of going back to what we did in the last lesson. If you have variable w times the variable w, we actually get w squared. And that should hopefully kind of make sense, right? This is actually kind of going back to when you learned about units in elementary school, right? The reason we have to use meter squared is because we're essentially saying you're taking one dimension here, the width, and you're multiplying by another dimension here, the length. And you know that when you add them up, when you multiply it, you end up with meter squared, right? And that's why you end up with meter squared, is because you're multiplying the two dimensions here. Well, it's the same idea here. We're taking the one dimension w times the other dimension 2w, and we multiply together and we get 2w squared. And we could also obviously use exponent laws. We know that we have an exponent 1 here and we have an exponent 1 here. And when you multiply powers with the same base, you simply add the exponents. So we get 2w squared. So now that we know what the perimeter is and what the area is, this question will become a little bit easier. To find the cost of this, we know that you're going to pay $2.25 for every meter. Well, we know how long the whole entire length around the table is. It's 6w, right? So if you want to find the cost of the rubber bumpers, all you need to do is take $2.25 and multiply by the total length that's going around this table, right? And we know that the total length going around this table, I'm just going to put this here, is equal to 6W. So all you need to do in this case is take the perimeter, 6W, and multiply by $2.25. So the total cost is going to be represented by $2.25 multiplied by the perimeter. And for the cost of the felt material, we're going to do the same. We're going to follow the same idea. We're going to take $28, which is how much it costs for every single meter squared, and we're simply going to multiply by the actual area of the whole entire table, which we found was 2W squared. So piecing this all together, you're looking at this, looks good so far, but you want to simplify this expression. So to simplify it, there's not really too much more that we can do, but there's something really small that will make it a little bit nicer looking. So we have $2.25, it's multiplied by 6W. Well, I have a number here and I have a number there and I'm multiplying, so I can simply multiply them together. So 225 times 6 is $13. Well, if we're thinking about dollars, $13.50. So 13.5W. And of course, 28 times 2 is 56. So we write 56W squared. Now for this question, it's actually one of the homework questions I've assigned. I started the question there for you. I did the bulk of the work there. But for the homework itself, I believe it asks you to find the cost of the material for a top that has a width of 1.5 meters. So I'll let you kind of figure that out, but you have the expression ready there. So all you're really going to have to do for that last part there is simply substitute the value that is given to you, right? But I really hope you still, like I said, the reason I assigned the question there for homework, even though we already did it here, it's just I want you to kind of practice with setting up an expression, okay? And I hope it kind of makes sense. These are I would say these are the questions where you really show your true understanding of what a variable is, right? Is when you're actually able to not just simplify an expression yourself, but you're actually able to create it yourself. And there's a homework. All right, best of luck.